Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm Steve Marks.
Hey, this show this week we're going to be talking about queues. That is the theory of queuing with Windows Azure as opposed to standing in line. Anyhow,
I thought the show was just brought to us by the letter Q.
Oh, well, it could be.
Yeah.
The next show will be brought to us by the letter K.
R.
Oh.
R comes after Q, Ryan.
Well, I know, it's not as cool. All right, and the news this week, we're going to be covering a few announcements from the SQL Azure team, as well as some cool samples that Steve has put together, in fact. Oh.
And some other stuff.
Yep, let's bring it up. So the first bit of news is the SQL Azure team has a white paper out on troubleshooting and optimizing queries with SQL Azure. It's available on the Download Center. Great resource in case you want to do either one of those topics, which I think a lot of people kind of do.
All my queries work perfectly and are as efficient as possible the second I write them.
I know. I can actually...
It's the same reason I don't use any debugging tools.
I know.
Everything's
the
perfect.
query plan, I just compile it in my head. I'm like, oh,
that's what I do
works.
too. Yeah, I'm like, which one should I do first? That'll be faster.
Yep, done.
Pre-optimized.
Yep. You don't even need it.
No.
All right, and then we have the SQL Azure Horizontal Partitioning Part 2, which begs the question, where was Part 1? Steve and I had at one point, I'm pretty sure, said something about vertical partitioning Part 1. I think we were making fun of the fact that it needed to be a series, and yet here we have a Part 2. I wonder if we said that. All right.
Moving right along, I think this one's also from the SQL Azure team. We have Vertical Partitioning in SQL Azure Part 1.
Vertical.
So I don't know what Part 2 is going to bring, but Part 1 is all about, and presumably, the title said Part 1, so I'm going to guess that there are going to be follow-ups to this.
There's at least one more.
I suspect so, although I think it would be awesome if they just stopped here. They're like Part 1 of 1.
Just kidding.
Yeah, exactly.
Okay, so in this horizontal partitioning, we have just advice on horizontal, which is many rows, same schema. So we take the rows and we separate them into different databases, but it has the same schema per table, as opposed to vertical partitioning, where the schema differs between tables.
Right.
And you split it out that way.
So this isn't really Part 2 of vertical partitioning at all.
No. This is completely different, and
so there's no Part 1 of horizontal partitioning.
Apparently not. But the cool thing in here is they do have some code that shows you this helper class, which shows you how to give you a leg up on actually doing that partitioning yourself for the horizontal case. So
I see.
So you take a look at this. It's interesting to read regardless. I know a lot of folks in the community, and I think last week we covered a sharding library that did horizontal partitioning called Enzo sharding or something like that. So, you know, you can look at the different techniques that people are using here, but they're going to kind of fall along the same line, which is choose your partitioning strategy and then go along that.
Yep.
Okay.
Moving right along, hey, this stuff is out there now. So this is really just the announcement that this is officially live and available in 6 different data centers. This is the 50 gig database support. That's probably the big, well, spatial data support is also something that people have been waiting for eagerly since they were announced. So these are live. This is actually rolled out. You can go use that. There's also something here, hierarchy ID types support, data type support. Easier said than done.
I bet you that has just something to do with hierarchical data.
That's what I think, but I'm afraid to say it because that word apparently gives me some trouble. But we'll call it tree-like structures because that's what it says here too. But yeah, I don't actually know what this is yet, but we are promised that there will be some blog posts in the future about how to use the hierarchy ID data type.
They should start with Part 3.
They should. Part 3, hierarchy ID data type.
Data type, and just figure out where the other
parts are.
follow
Following on from the other one. Yep.
Now, one of the events that has been going on, or it wrapped up recently, but has been going on around the world, has been the amazing Vittorio Bertocci delivering basically an identity workshop, and it's been going, like I said, around the world, different locations. We recorded those sessions, and one of the sessions, which is very worthwhile for a Windows Azure developer to sit through, is the WIF and Windows Azure session. I don't know if they like WIF. I think they go WIF.
Let's just call it Windows Identity Foundation.
Yeah. WIF is a little catchier.
We don't call Windows Azure WA. Well, sometimes we do.
Yeah,
All
I
right.
do. So I call it
Whiff and whack.
Waz.
Yeah.
So
cool.
anyhow, this session has Vittorio going through and delivering on how to get Windows Identity Foundation and Windows Azure working, how to do the federation and whatnot. And he's very explicit in couching these terms to Windows Azure. So the little things that are different. If you know the theory about how Windows Identity Foundation and federation works, that doesn't change at all for Windows Azure, but what does change is some of the very specific implementation details, and Vittorio has a really great analogy in here about how that works. So highly recommend it. It's worth your time sitting through. Vittorio is a great presenter. All right.
Indeed. Next up, in the vein of things you can consume that will make you smarter, I don't know, that was the best transition I can come up with. There's some Articles from the Trenches, Volume 1, which I can only assume means that Volume 2 is going to be about an unrelated topic. But but this is basically, my understanding of this is a bunch of people, 15 authors in fact, contributed articles to this and sort of put it together as a free ebook that you can get. So you can just download this and read it. The cover looks pretty cool. I haven't actually read it myself yet, so I have no idea what's in here, but I recognize some of the names of the authors, and that they sound like people who do know what they're talking about. So I would check this out. It's free, so it's definitely worth it.
Yeah.
Regardless of what you get out of it.
You get what you pay for.
At least that much.
A minimum. But the guys, what's great is this, since it's from the trenches, these are supposedly folks who's actually gone through pain, and they're giving you some learnings.
This
some
isn't just
valuable
us
tips.
making stuff up. This is people who've tried something, actually accomplished something with their lives, telling you what it's like.
Exactly.
Last up, some obscure blog on the internet.
Yep, I saw this. I don't know if Steve has seen this, but some guy put together this Netflix thing. It's awesome.
Let's just click through and look at it and come back to the blog post.
Essentially, this is how you should navigate Netflix for instant watch movies. And you should just completely eschew the Netflix site. I'm sure Netflix enjoys me saying that, but it's true.
I'm sure. No, this is a cool visual way to browse Netflix. This is made possible by the Pivot Silverlight Control. I guess it's technically the Pivot Viewer Silverlight Control, which shipped just this week. And this is taking the Netflix OData feed. Followers of this show are not strangers to OData.
Right.
Pulls it all in, puts it in this cool UI, lets you kind of click around, and of course you can jump out and go to the Netflix site with it.
But you discover so much more when you can actually visualize the data like this. Like if I wanted to say, look, I want every comedy that has a greater than 3 rating in the rated R category or rated PG-13.
No, we're doing it. PG-13 comedies rating greater than they're all greater than 3.2. Let's go greater than 3.6.
Bam.
There it is.
That's what you can select, and then you can like sort it by year as well. So you can pop it out and just say, oh, what year? Let's look only at the year 2005.
Oh, I only want the 80s. I'm sorry.
Is Raising Arizona in there?
Yes, it is.
Oh my gosh. Now, if they only had the Big Lebowski.
Resort it by rating. That is actually the highest rated of this group.
Yep.
Is Raising Arizona.
Well, it's a classic cult comedy, right?
Okay, let's not spend the whole show talking about Netflix. But there is a blog post here by this funny-looking guy up here, Smarks, and he says, I'm going to get confused with these pronouns. It only took 500 lines of code for me to write this.
Wait, you wrote it?
And that's, sorry, the cat's out of the bag. It's actually pretty cool. Almost all the important code really is in the blog post itself, in the text here, and then you can download the rest of it down here. So kind of cool. I think it's worth checking out. If nothing else, it's a good way to find movies to watch on Netflix.
Yeah, if you're not interested in actually how it was put together, you could just completely use it as a real application.
Then just use it. Yeah, I mean, that's
you should lobby Netflix to adopt this interface because awesome.
And you know what feature this doesn't use at all? Queues, which brings us to our feature.
Great transition.
There's literally no use of queues. There's a worker role and whatever, but it all does it on one VM. So there are no queues there. But that's what we're going to talk about today is queues in Cloud Cover Queues Part 3.
Yeah, so this is actually the third installment.
Yep.
Just
Part
try-
1 and 2 were blobs,
just
but this
try-
is Q's part 3.
Yeah. Part 1 was tables. Part 2 was blobs.
Yeah.
Okay.
So let's play with some Qs. As you see here, I've got, we don't need this anymore. I've got this awesome program already written.
Yeah. Looks complicated.
It doesn't do anything, but I basically went to the Windows Azure portal, set up an account, and we're going to use it to play with queues and just show the basic API and how these things work, and then touch on a couple more advanced scenarios. And then we'll wrap up with a tip that's actually also related to this. So
what's interesting about queues, though, is they're technically, they fall under the storage, but really they're not really about storing data as much as they are about facilitating communication between different roles. So it's a queuing mechanism as opposed to...
Yeah, it's more communication,
yeah,
right?
But it's communication oriented, but you have to have, you could create the storage account and get all these things. So.
And the reason is because the messages are actually persisted in storage, which means they have all the same properties as the rest of storage. They're replicated 3 times. They're durable and centralized, so you're not going to lose them and things. That's why queues are implemented on top of storage. That's why you need a storage account for it. So here I've just written some code. So we're basically going to do 2 console apps because I just didn't feel like putting it together into a Windows Azure app. It's a little bit simpler, actually, just seeing a console app. You can imagine one of these a web role, one as a worker role, or they're 2 different roles or something. But it also underscores the point that, as with all storage, you can use queues from a standard desktop app or from anything. You don't have to be running in Windows Azure to make use of them. So we're using the actual cloud storage and cloud queues. But we'll do it from a local thing. So I've got a producer here that's going to basically put a message on the queue, and then we'll write a little consumer that takes messages off and does something with them. So the first thing that I did is I got a reference to a queue, and then I said create that queue if it doesn't already exist. Normally you probably just want to do this exactly once, just create the queue exactly once. It's sort of wasteful to do this. Don't do this in a loop or something.
Right.
But for now, that's going to just make sure that the queue exists.
I typically provision queues and tables and things like that before my app starts. I have just
I do too.
I just provision. It's not even part of my app. It's just an assumption that you have. It's same thing as like you create a database before your application
You don't have
starts.
the first line is if the database doesn't exist, start
Create a
do all the
database,
creating, whatever. I have a hard time sometimes with samples, figuring out how to share code with people that requires that sort of setup.
Yeah.
And
PowerShell.
at least once I have shipped a separate script that does all the setup stuff, but I tend to sort of get lazy and do this sort of thing. It's okay if this really only happens, for instance, when a role instance is starting something. It's just one round trip to see if the queue exists or something. That's not a big deal. What you want to avoid is every page view or something like that. It does this. Okay, so we've created our queue. Let's put a message on it, because the basic operations on a queue, you can enqueue a message, you can dequeue a message.
You can peek.
You can peek at the message. You can
Delete
delete
a
messages. Okay, there are a few things. But enqueue and dequeue are sort of the top level things.
The bread and butter of queues.
And so, naturally, the enqueue message is called put message. No, add message.
Not
See, I
enqueue.
couldn't even remember it. And it takes a cloud queue message.
Right.
Okay, and you can put anything you want in there. You can put binary data in there if you want. There's a nice constructor for it that takes a string. If you want to put something in here, foo. You can also put binary data, as we said. There's a limit, which we'll talk a little bit more about later. But the rough sizing here is 8 kilobytes for what you can put into a single queue message. And then we'll talk about sort of some consequences of things.
Little caveat.
So let's actually have this use something passed in on the command line. So let's just use arg0. Nice error handling I do there in case I don't put an argument. So we'll add a message that comes from the command line. And that's going to be it for now for our producer. So this is just a command line app. I can run it. I can put a message on there. It'll go in the queue. Let's run it to make sure that I'm not crazy and it's working so far. So this is the producer. Go here, producer, hello world.
No error, must work.
All right. It did indeed, we think. Okay, this is probably small. Should we bump up these, bump up the font? I can do something like that. Just a little bit easier. We're gonna have to do it in another window in a second. Okay, so, we've added a message. Now the next step is, well, what does it take to
consume it.
dequeue that message and consume it? Here we have to talk about a concept, I think, before we go any deeper on this, which is that these are reliable queues. And we've talked about this before, but it's worth repeating, especially as we look at the API. Reliable queues mean you want to guarantee that at least one consumer gets this message, so somebody handles this message. To do that, you need to deal with the case that somebody takes the message and then they just keel over and fail.
Yep.
So you need some way for that message to reappear. In our queue system, and in most queues that are built with this constraint, that means that when you dequeue a message, you actually haven't gotten rid of it yet. You've just sort of made it invisible. So you sort of got a lease on it. You borrowed the message for a while. You have that time to work on it, and then you go and say, okay, I'm done, delete it. That way, if you keel over in the middle and don't finish it, it'll just reappear after some period of time. Okay, so you're going to see here we have this kind of two-phase dequeue. So I'm going to write a loop here. I'm just going to say while true, because this is really common when you're using queues to end up writing this loop forever. We're going to need the same, we can copy paste that. We're going to need the same queue. Actually, by now I know it already exists, but I'm still going to leave it in the create if not exist. So if we got that queue, we're going to say queue.getMessage. And then
If message is not null.
if it's not null, so if there's no message, this queue.getMessage, it won't block or anything. It'll just return right away with a null, right? And so if the message is not null, then I always do this before I write any other code, is I remember to do my delete message at the end of that. So if I got something off, I need to remember to delete it when I'm done with it. And in here, we're just going to do write line received message dot as string, because remember you could put anything there, so as string just sort of treats those bytes that are part of the queue message as a string, and so give it back there. So this will basically just print out. The last thing you should really remember to do is actually let's just put in a thread.sleep. Sorry, I need system.threading up there to do that. But let's just put in a thread.sleep in this loop. That's, I don't know, 10 seconds in between each message. Remember to put something in here, because whether you're running locally or you're running in the cloud, where in the cloud you might not notice it, but locally you probably would if you're in a tight loop, you don't want to get into a tight loop that's pulling your queue.
As fast as you can. You'll get throttled.
And yeah, I mean, one of those reasons is the storage system will literally see that you're flooding it with requests really fast, and it will start responding with a
503.
503, is that it?
503, yeah.
503, which basically says you've
Back off,
been
buddy.
throttled, back off. So you don't want to do that, because you will actually get restricted. Then you won't get any queue messages. Right. You'll start to get really bad results. The other reason is that there is actually a cost to each one of these polls of a queue message, because each time you call into the storage service, a transaction happens. So it doesn't matter what you're doing. And in fact, even if you're just saying, hey, are there any messages on the queue, and the answer is no, that round trip to storage and that message was a transaction. Now, transactions are 1 million transactions for $1, as I like to do it, or 10,000 for a penny. So you might think you can do a whole bunch of transactions before you notice it, but computers are fast, and a tight loop that's just doing round trips to storage continuously, you can actually eat up a bunch of transactions that way.
Well, if you're running a single instance, right, that's one thing. But when you scale out,
then you're running 50
instances. You gotta. There's a multiplication factor in there as well. You got to keep that in mind.
So what I tend to do is I tend to do this.
Right.
Which basically says, okay, if I got a message and I did something, then go ahead and get another message, right?
Yeah.
But if I didn't get a message, which meant the queue was empty when I queried it, now put in a sleep, and I usually don't sleep for 10 seconds, but it depends on the kind of app, right? That means that when it's empty, you're going to wait a long time in between it. But when it's full of a bunch of data, you're going to keep churning through it. This is reasonable for a lot of kinds of applications where the queue gets flooded because some work just got added, and then it all kind of dies down later.
Right.
Not all applications are quite like that. So there's some, especially if each queue message takes very little time to process, there's some cases where you might want to think about that timing just in general. But this is a pattern that will get you a long way. In here, I'm just going to put the sleep in anyway, because I kind of want to get to observe it over time. Right. So let's build that, and then let's fire up another command window. and this is the consumer. And let's just run the consumer. And the first thing you see immediately, hello world popped up because we enqueued that earlier. If we go back to our producer and add another message.
Use that Windows Snap feature.
Oh, I could do that.
It was my idea.
Windows 7 was my, damn it.
Haha, beat you. I totally thought of that in the shower.
So there you go. So I just
Actually,
ran
the guy did
producer thing.
look a little bit
There
like
was
you.
a little, yeah. Okay. Little similarity there. I was the inspiration for that. That ad campaign was my idea. So hello world, another message. Foo. Now it's just fun. So each message is coming there. It's showing up here exactly once because it's pulled off the queue. Mm-hmm. We print it out and then we delete it, and so that means it's never going to show up again. Let's make this do something more interesting because I took the time to write this code and we might as well use it. If you see up here in my consumer code, I have this suspicious thing called to-pig Latin. Let's make use of that. So when we're printing out the message, let's convert it to Pig Latin.
What country uses Pig Latin?
The nation of
Pig Latinia?
Porkistan. To Pag Latin, that doesn't exist. All right, let's rebuild. Build succeeded. Let's run our consumer again. Let's try hello world again. There is a 10-second sleep in there, so occasionally it takes a while. Elohe Earldway.
Whoa! So what you're saying is the queues actually reverse everything into Pig Latin for you.
Right, that's actually a feature of the queues.
That's a feature of the queues.
I just turned on the Pig Latin thing. It's just a bit that you set when you create the queue, and it comes out that way. No, Ryan, that's not how it works.
Oh, okay. I must have missed the demo.
So, so just to show that we're doing something with these messages,
right.
We'll kind of do that. Plus, it's hilarious. So, Ryan is awesome.
Yeah. How's that go?
Let's find out. Iron Ray is way awesome way. Okay.
We could do this all day.
So let's do something else here. Let's go to our producer and add a feature. Let's just say int count equals 1. If args.length greater than 1, count equals int.parse args 1. So this basically says, let's add a command line option. Mm-hmm. You can optionally put a count after here. And then I'm going to do a loop.
For tab.
I did not know that. Thank you, Ryan. I like to type things by hand. It takes me back to earlier days, simpler times.
Simpler times. Back when we used to fight the tools.
Yeah, exactly. Okay, so now I can say Ryan is awesome 8. This is going to take forever. 10 seconds delay in between each one. That's going to be 80 seconds. It's going to be a minute and 20 seconds.
Probably should have gone with the other pattern, which is pull
probably.
as fast as you can.
Probably should have. But there's something else we can do. All right? So we could poll as fast as we can. Actually, let's do the poll as fast. Are we going to get throttled if I...
Nah. Not for 8 messages. Now, if you...
As long as... Let's put in the else then. Let's go to...
So remember the scalability targets for a single queue is around 500 messages per second. So you're going to get 8 off, and then you're going to get an empty message, and you'll be okay. But
because I'm going to sleep if I get an empty message.
Right.
So
exactly.
So we're not going to do a full tight loop. We're going to do this sort of thing. Okay. Let's try that then. That's a good idea. So now it's just going to crank through them.
Yep.
And done. But what if we did like
10 million.
Hello Ryan 1,000.
Well, first of all, you're making 1,000 individual puts.
Yep.
Into the queue.
It's going to take a while.
That's going to take a little bit, especially since we're not sitting right next to the queue up in the cloud.
I deleted the 0. Let's make it 100.
Yeah.
So it's going to take a while. It's actually still it hasn't returned yet from the producer. Mm-hmm. So it's actually still enqueuing these things, and you're seeing them come in here sort of one at a time and whatever.
But this is relatively inefficient.
Yep,
right?
this is wasteful in 2 ways, right? It's wasteful on the producer enqueuing 100 different messages, and we can talk about ways to deal with that later. But it's wasteful in another way, which is that there are 100 messages sitting on that queue, but I'm reading them one at a time for no apparent reason, right? So we can deal with that on the side of the the consumer, right? So let's do that one first. So let's take the consumer, and let's replace this. So instead of getting a single message, let's get a lot of them. So there's another method here, get messages, which takes how many you want, and it's up to 32. So don't try to do more than that. You can get up to 32. And now things change. Now we should probably have a for each message. Let's do this. Messages, for each message in messages. How does this work? There are delete messages? There is, right?
Yeah. No, it's delete message.
Oh, okay. So I still have to delete each one. Okay, great. Yeah. Then I did this right?
Yeah.
I still probably want to have a. I can just do it here. If messages, I think I always get back something, but it's an empty set. So I think I can do, you know, if the count was 0, then sleep. We're just making this up as we go. Who knows if this is right? I think it'll work too, but I've been wrong before. Okay, so we rebuilt that. Let's run our consumer again. I'm not sure if anything is in the queue that we haven't already processed because it was chugging along.
I think it is, right?
Well, I stopped this before I stopped that one, and I think it was actually caught up. So I'm going to do hello again, and I'm going to say 100. And this is interesting. We're actually setting up an interesting race condition because we're running the producer, which is doing one at a time at the same time as we're doing the consumer.
Yeah.
And so probably not the best way to illustrate this.
You want to run the producer for a little bit before you do the consumer.
Fine, let's do it. It's actually still running, so let's let it run and do the rest of them. Then when we run the consumer, we should see it just sort of blast out, 32 at a time, depending on how many are left to do. And so basically, the learning here, right, is that, okay, so that's done, is that you should go ahead and get the messages quickly, right? So here it's fetching 32 at a time and then just sort of printing them all out. Probably should have put some messages that showed that. But, you know.
Got message 1, 2, 3, 4.
But good enough. But trust us, it's getting them 32 at a time and sort of burning
Well,
through
it'll
them.
get up to 32. So it's not guaranteed you're going to get 32.
Right.
Obviously, if you ask for 32 messages and there were 5 in the queue, you'll just get the 5. And also, there's kind of a limitation in there as well, as it'll do its best effort within the time span that you've allowed of wait to get the messages. Now usually that's pretty quick, but I've seen if you have a lot of workers and you're pounding a queue with lots of messages and you ask for 32, it's not unreasonable to get 10 or 5 or whatever it is out at a time, because you have all these producers asking for the message at this exact same time, asking for 32. So the way the system doles them out to make sure it's not duplicating it, you can get less than 32, and that's the important part to take away.
Yeah. Let's go revisit, let's actually go back to the version we had before with a single thing at a time, because I want to talk about the invisibility timeout, and it's just easier to illustrate it with a single message, right? So if we're getting a single message, one of the options to get message is a time span, which is the visibility timeout. So this is the time between when I retrieve the message from the queue and it's how long I have to delete it before it reappears again. So it's the time from when I get it to the time it reappears again automatically. The default is 30 seconds. The maximum is 2 hours, and we think the minimum is 1 second because it's an integer in seconds. And so, so let me actually set it to 1 second. Okay, so we're living on the edge here. Now this should actually be okay here because all I'm doing is printing the thing out and then deleting it again. I should be able to do that within the second.
But if you put a thread sleep in here,
pending latency and whatever, I was gonna do something better than that. This is gonna sleep till I hit enter. So basically the way this code works now is I'm gonna get the message, print out the message, and then wait for the guy at the end of the keyboard to press enter. And then delete the message, and we'll see.
But that'll work.
What happens? That won't work.
No, it'll work fine because as long as no one else has popped it, you'll still be good. What won't work is if you ran 2 of these and then popped it.
Correct. Oh shoot, I should do that.
Yeah.
Well, we should show that anyway, actually, because you need to see that. Let's run another one.
Yep.
Okay, so we've got 2 running. I'm going to send one message through. One message. I'm not going to put a number after it, so it's going to default to 1.
Now, one of the consumers is going to get it. Right?
And this guy got it.
So,
and now he's waiting for me to hit enter before he deletes.
Right. So now it's visible. So
and then, hey, wait, the other consumer got it because after
Exactly.
a second it reappeared again.
Yep. And then
Okay.
it's going to happen again. No, but it will actually. So the second guy, the way this works is when you get a message, you actually get what's called a pop receipt.
Yeah.
And the pop receipt is what you have to send into the delete message, which is why that delete message takes the message as a parameter. It'll look at that pop receipt. Now, the concept here is that your pop receipt is valid as long as someone else doesn't pull the same message. So whoever the last person that pulled the message is the one that has the valid pop receipt. In this case, we intentionally pulled the message twice. The second one got it, but the first one still thinks it has
Right.
it.
The second one is just waiting. It's about to do this q.delete message. Little does it know that in the meantime someone else has the message, and that means its receipt is invalid. So if I press enter here, unhandled exception, the specified message does not exist.
And then we crash the entire machine.
And then the whole machine crashes. Now over here, what you're saying is that because no one else has DQ'd this since I did over here,
He's good.
This pop receipt is still valid. If I hit enter,
Completely valid.
It should go ahead and do it. And so it did. It went ahead and deleted it, and now it's sitting waiting for the next message
Right.
and continuing to work. So that's adding a message. That's getting a message. That is using the visibility timeout.
But this is the important part here is you didn't have any error handling on delete message.
Correct.
And so you crashed.
Yep.
Now in the cloud, if you did this, if this exact code was up in the cloud and you didn't handle the exception, your role would recycle.
Yep.
And it bubbled all the way up to the top, right? So the key here is to make sure that you are handling conditions, especially when you have more than multiple consumers, you're handling the condition where you need to actually validate that the delete occurred. You can ignore it, right? You can catch that exception. There is a valid number there, and you can just say, "Oh, someone else got it."
Right. I mean, that's generally what I want to do with when delete message fails. There are lots of things you might try to do, like delete message failed. Oh, wait, let me undo the work I just did, or something like that. You'll get into a lot of trouble if you go down that path.
Yeah.
It's probably a good idea to just ignore that, because the way that you've built your system is that it might fail at any time, and so the next guy who got the message is able to just carry on with the calculation. It's going to work. And so ignoring it is sort of an okay thing to do. And so I generally sort of put a try catch around the delete message, and specifically look for what you want to do anytime you're doing a try catch around these things is look for the right error code that matches to the queue message doesn't already exist. I don't know off the top of my head what the error code is, but
Yeah, I forget what it is, but you can
we can try
actually you can actually catch it.
Storage error code dot. Oh, it's not queue message doesn't exist. The specified message doesn't exist. Is it perhaps
405.
message?
It looks like a 404.
Hey, I don't know which one of these it is.
Well, we'll have to look it up, but you can
Interesting.
actually figure
Yeah,
out
we
which
should
one
we should
is.
look it up.
Well, there's error code and there's status code, right? EX.status code.
They're
be
both, and
status.
yeah. We should figure it out and put it in a comment on the thing or something. But there is a right way to do this to make sure that you have the right error code. I don't know. It could be that it's not in the error codes at all, and it's in the there's another one that's a sort of the error code string, and you can match on that. I'll figure out what the right one is, and we'll just add it later to the show. So right, so you should handle the delete message failures. You should set an appropriate timeout, the visibility timeout, because you want messages to reappear. This is something we covered last week. You want messages to reappear somewhat quickly, but you want to make sure you had enough time to do the work. So think those things through. We sort of touched on idempotency as we talked here, but we should have a discussion about that. It's important that because we have this reliable message delivery, these reliable queues, it means you'll get every message at least once, but you might get it more than once.
Right.
Specifically, if you take it off and then keel over and then it reappears, that can happen. In general, you should just assume that it's going to happen every once in a while, that you're going to see a message, a duplicate message. So it's important that the work that you do based on the messages is idempotent, which means that if you do it more than once, you still get the correct answer at the end. So the common thing people are doing is, the queue message specifies that, hey, I do work on this thing and I put the result here. And if someone else starts doing the work and overwrites my result, fine. We've wasted some time, but we have the same number at the end or the same outcome. It's important to design things that way. Messages are also not guaranteed to be delivered in the same order they were enqueued. Just in general, this can happen just because of the timing of a whole bunch of machines hitting the service at the same time.
Visibility.
But it can also, the
impact
visibility
it,
timeout
right?
makes the same thing happen. When this thing becomes visible again, you'll pick it up later, even though it was the first message in the queue or something, right? So you have to be able to deal with getting these things out of order, which means you also have to have the work be commutative. So commutative just meaning, you can switch the order and the outcome is the same. So the example that I like for this one is, if you were doing a banking application and you had accounts and you had withdrawals and deposits, and you had an alarm when it would dip below 0, if you got these in the wrong order and you saw all the withdrawals before any of the deposits, would your application work correctly? And this is the sort of thing to think through up front can I deal with sort of any ordering of these messages and still doing the right thing? So commutative and idempotent are sort of the big things there. What else did we want to talk about before? We've got a tip coming up.
So we're talking about here the sample that we have is we're putting a whole bunch of messages on the queue, which by itself is it can be if you want to put 1,000 messages on the queue, it depends on what the queue message represents, right? So if you're enqueuing 1,000 items onto a queue, and each one of those items that you enqueue is like a task to do, you have to also question whether or not you should be batching those up. And by that mean making the queue message a little bit larger. Let's say that you had 1,000 messages and you did this regularly. Maybe 1,000 is too small. Maybe you're doing 1,000,000.
Yeah.
You don't want to push 1,000,000 messages on the queue. First of all, we currently don't have a way to batch send a message into the queue. So it means you're going to have to do a transaction for every message. It might be, and it is worth your while in that case, if you have lots and lots of data to put onto a queue, go ahead and maybe write all that into a blob, then drop the message into a queue that says, go read the blob to get all the work that you need to do. So batch up the stuff you have to do, and then put it into a queue message. So you want to make sure that that message is chunky. It means something more than just an atomic operation, unless you have a few of those, right? And that's the other tip.
Yeah. And actually, it's important to note also that even on the consuming side, where you can take things 32 at a time, you have to call delete message on each one.
Yep.
As I just learned as we wrote this code. And so you have a round trip for each one of those. So even if you think, 32 is going to be enough that at least I'm pulling I'm not too worried about it or something, you're still going to have a round trip to do the delete for each single one. And so a bunch of reasons to consider batching these things up. And so either make longer queue messages. I promised we'd get back to that, so we should actually talk about that gotcha about the size of queue messages. But either make longer queue messages or put these in a blob and queue a message that says, hey, the blob is called foo, right? And so the queue can just be a reference to things, right? So we should talk about the size limitation, because this is something Ryan and I were just talking about before the show, because this is fairly counterintuitive, let's put it that way. So queue messages have a limitation on length, which is 8 kilobytes of data. That's right. And that is true. Okay. However, the way that queue messages have to be formatted is that they have to be embeddable in XML, because the actual REST API underneath all this is an XML-based API. So the message is going within XML. The .NET Storage Client library encodes for you so that no matter what you put in here, raw bytes, strings with a bunch of funny characters, etc., it will be able to be put in XML. And the way it does that is it uses base 64 encoding. So whatever you put in a message using the .NET Client library will get base 64 encoded and then uploaded as the queue message, get pulled down and then decoded.
Right.
That means that the real limitation is that the base 64 encoded version of what you put in here can't exceed 8 kilobytes. And what in practice comes out to about 6 kilobytes. Because base 64 encoding tends to sort of expand, because it uses a limited character set, right? So it expands things by about 50% or so, I think.
No, not that bad, but 20% or something.
But it does in chunks of 3 or 4 bits? I don't know. Anyway, math aside, 6 bits maybe it is. I think it's 6 bits. So it's 24, it takes 4 instead of 3, so it's like a third increase, something like that. The math comes out, well, that would be 6 to 8, right? So actually, there you go.
The math
6
is
kilobytes
6K into 8K.
goes to 8 kilobytes, which means 6K is probably the rule of thumb you want to think about. You may also want to think about the logic you have. If you're bumping up against that, if you're intentionally trying to cram a bunch of stuff into the queue message, one thing is you might move it out into a blob, but if you're trying to do that, you may be bumping up close to this limit. Either check the base 64, either base 64 encode it and check the length yourself, or handle the error when you try to insert this and it says it's too big. So just something to look for. If your messages are very small, you don't have to worry about it. But as you get close to that range, you should think.
One of the other interesting implications that comes out of using out of this, the base 64 encoding, is if you have different technology sets consuming and producing queues, you can get into a little strange situation. You would actually have to know who produced the message in order how to handle it. So, for example, if you had a service that was the .NET client was producing messages, and then you had a service that was reading it back, you're going to get base 64 encoded stuff back. So you're not getting this pretty as string. You're going to get some blah. Right. You need to know what to do with that, and that's the other slight gotcha on that. Obviously, if you use a .NET client, it's going to work both directions. It's going to round trip it just fine. You just need to keep that in mind. If you had like a PHP application or a Java app, that just assumed it was going to get that string that you pushed in from the .NET client side back, you wouldn't get that.
And the other way around also, if you're using the raw REST API, you put something in that's not base 64 encoded. .NET client library tries a get message, it'll try to base 64 decode it and die on invalid input, right? One more, before we move on to the tip of the week, I just remember there's one more thing we should probably mention, which is peak message. And one way to do that is if we go to the interwebs and go to this little app that I'm not sure you guys will have heard of. And Ryan, I don't know if you're aware of this, but there's this thing called My Azure Storage.
This guy's probably phishing your credentials.
Which is written by Ryan. So Ryan and team own this, and let's put in, what are these credentials that we're going to let them sniff? Hey guys, everybody gets to see my account key now, but it's an account I just created for the show, so I don't really care. Hey, wow, selecting is kind of hard when you're scrolling the whole time. All right, let's copy paste that in here. Let's log in. This tool is handy for a bunch of things, but you'll see it uses a couple things. It has the approximate message count, which is another API that we try to simplify. Say it's NQ and DQ, but there's some other stuff. Approximate message count is one of those things. It is approximate. It's sometimes fairly wrong, and in fact, notably, it includes everything that's invisible but not yet deleted. So if you're in flight on a message, you'll go here and you'll see, oh, there's a message in the queue.
But I can't read it.
Right, but you can't actually find it, right? And that's probably what it is that somebody's DQ'd it. But it's also, especially if you're really hammering on a queue, it's really an approximation. It's not always up to date. Yep. It's just sort of a best effort thing. So what should we do here? Should we let's run the producer a little bit first. That's not the one. Producer, hello, 10.
Sounds good.
It's going to go put these up in the queue.
As long as you don't have a consumer popping them.
Right, and nothing's popping them off at the time, I think. Right. So now we see approximate count of 10 messages. If we click on it, we can actually see the messages. And this is interesting because, what I hope didn't just happen is that all these messages got DQ'd and deleted, and now that's it. And so my consumer can't see them. But gratefully, there's this message over here. Don't worry, we just peaked at the first 20 messages in the queue. Well, there are only 10 here, but this uses a peak message operation, which is basically like DQ or like get message, but it doesn't actually mark it invisible. So it gives you back the message, but no valid pop receipt to delete it. It doesn't make it invisible, and so it's a way to just kind of look at what's on there without doing anything else. And like with get message, you can do that in batches. And so that's what this is doing here. Is it's giving us sort of a glance at this.
You'll notice the peak API as well doesn't allow you to pick out a particular message. So if you enqueued 100 messages, you can't say peak the 100th.
Right.
When you peak, it's the same as if you did get message, which it takes whatever whatever.
gets what's
it
over the
pops
top.
whatever is on the top. So you can say, give me 20 or give me 30, but you're not going to be able to pick a particular message. That just goes against the
Right. And it
the
should also be
philosophy of
noted that
queues.
you can't, if you peek a message and then go, oh, great, that's the one I want, and
You
then
can't
go
pop
get
it.
message, who knows what you're going to get, right? You're going to get whatever the queue system gives you then. Certainly in the case of multiple threads or multiple machines doing this, somebody else will have gotten that already or something. But it's not guaranteed. Peek message just sort of gives you a view of needs. So the only use I've found so far for peek message that I've used is this sort of thing of just like looking into the queue. Hey, what's going on? Like something's weird. Is there anything funny in the queue? You can also create messages using my Azure storage, which is kind of cool. That one is one that apparently Ryan has typed in before, and so just added that to this queue. The insertion time and expiration time aren't here, and I think that's because the create message just added this to the UI. It didn't actually do a peek message again.
That's exactly right.
Probably
if you did a refresh,
if I
it would show
refresh
it.
this, yeah, we'll see it at the bottom here.
It's all
doing this.
Ajaxy, so it didn't want to make a round trip.
Right, right. So if we run the consumer again, we should see all those messages come off, including that last one.
Yep.
Hey, why did I only get one thing off there?
I think we're taking one at a time, and you have the key. You have to start hitting enter, right? Read line.
Oh.
Are you read
Oh,
line?
did I not save the? Oh yeah, no wait, the read lines. All right, Ryan's smart. Okay.
There you go.
Uyeyakse. Look, it doesn't handle punctuation very well. It's not very graceful.
Yeah.
Okay. So this is handy. So two things, right? The approximate message count and peak message as APIs you should be aware of. And also, this is a good tool for just playing around with queues. Since you can create a message very easily in the UI, you don't have to bother writing up some little test client that inserts a certain message just to test something out. You just go here and type it in. As long as it's a string, you're okay. Using this kind of tool to do that. All right. We should move on, I think, to the tip of the week, and for that means we need some sort of intro.
Yeah, I was
tip of the
thinking,
week.
the people in the UK, when they say queue, they actually mean line.
Yeah,
And, they're incorrect, of course, because a line is a line.
Absolutely.
You don't queue up.
they drive on the wrong side of the road too,
Yeah,
don't they?
it's
Yeah,
backwards,
a bunch of stuff.
everyone.
But they do measure things correctly.
in meters.
That's no.
Oh, in pounds.
Yeah. Anyway,
So, now, I was thinking for the tip of the week, we could see what a queue looks like. A UK version of the queue looks like
all right.
around the world. So, you can see some pretty interesting folks in a line
Yeah.
or a queue. I'd like to see
Doesn't
that.
the whole world call it queues except for us?
I don't know, but
Isn't that sort of like I think everyone who speaks English other than Americans says queue for that. It's confusing.
I don't know.
Okay,
what
so
do
anyway,
Canadians do?
I don't know.
We'll have to ask the Canadians. Hey, by the way, if you're Canadian and you watch the show, can you give us a shout out at Cloud Cover on our Twitter account? We'd
And
like to. We'd
tell
like
us.
to. We'd like to know is it
Please let us
queues or
know.
lines?
And don't tell us it's something in French,
yeah.
because that's not what we're looking for. Okay, so with that,
Here it
here's
is.
your tip of the week.
Tip of the week. Okay, what is the tip,
Interesting
Steve?
as always. So the tip this week is about how to spell Q, because I find it's very difficult, and I have a little mnemonic here, which is if you're like you want to create a Q message, what you do is you type the letter Q, then you type UE, and then you keep typing UE until it lights up and looks like the thing that you're looking for. Right?
you go.
And if you type too many UEs, then you're going to get the squiggly line, nothing matches sort of thing. And so that's the tip.
Thank you.
No, that really wasn't it.
I would hope not.
Ryan was scared. Okay, I do actually have
I know what the tip of the week
a real
is.
tip.
So
Yeah, but I can just change it. I mean, what are you going to do? You're just going to go, no, Steve, that's not the tip. Here's the tip. I mean, I've got the laptop. So clearly,
It's my laptop.
Clearly, I'm in the,
I'll unplug it.
That's true. That's true. It has a battery. Okay, so let's see if we can make this thing crash. Actually, let's because I actually haven't tried this out. I have this idea that this is going to be related to letting the thing crash. I took out the read line, by the way, so that we don't have to worry about that anymore. Let's get rid of the other consumer because we don't need him. Okay, producer. I'm just going to put an empty string, and let's find out what happens. I think I have a bug. We'll find out in a few seconds. The consumer should pull that off. And
Crasheroonie.
invalid operation. It's basically in the Pig Latin stuff that I have. It looks at the first character to see if it's a vowel or a consonant. That's how Pig Latin works. I learned from Wikipedia. And if the string is empty, it doesn't deal with that. It tries to get the first character of that. And so it crashes. Now, the crash by itself isn't terribly interesting, but let's look at what would happen if you did the sort of typical thing that you do with queue messages, which is you put this all in a try-catch, or you just don't handle the exception and your role instance, for example, gets recycled, or whatever process you're doing gets recycled. So we're just going to put some generic exception handling here that says, that prints out the error, okay? So I'm going to rebuild. Now note, because we crashed before we deleted the message, it should still be on the queue.
Yep.
So if I run the consumer, let's clear the screen. If I run the consumer again, it gets the message, it throws an exception, it prints it out. It gets the message again, it throws an exception, it prints it out. Gets the message again, it throws an exception. So this is just going to happen forever. Never. Let's wait and see if it stops. So what do you do with messages like this? And in the literature, you'll find this as though
poison message.
Yeah, poison messages is the name for this. And basically, it's some message that somehow, when it comes into the system, causes things to fail. And in a reliable queuing system where you keep seeing the message over and over again until somebody deals with it, you will get this behavior of looping forever. Now, I could squeeze some other messages in there, and some of them would make it through, but every once in a while, this message would come basically every, 1 second, and since that's what I've set the timeout to, but typically a longer time, but every couple minutes or whatever, this thing's going to reappear, somebody's going to pull it off, they're going to crash, and they're going to start over again. So there is a way to deal with that. There's a feature in queues called the DQ count.
Right.
And how do I get that?
It's message.dq count.
Q.dq count?
Message.
Oh, message,
MSG.
sorry, right. Message DQ count.
Yep.
So we're going to put some code here that says if the message DQ count is greater than 3.
4. Because 5 is a good number.
Now we have to wait for 5 of these to happen, though.
Well, you already DQ'd it.
Oh,
like
we
10
DQ'd it a
times.
few times. That's a good point.
It's going to just
okay,
delete.
wait, maybe let's go to 8. Okay, so, because I don't know how many times I did it. So we're going to basically say, I sort of reverse the logic here. I'm saying if we've DQ'd it less than 8 times, go ahead and print the message out, do the work, right? Which in this case is just converting it to Pig Latin. Otherwise, delete the message.
Right.
Right. Well, it's going to delete the message anyway, but but this is
well, it's going to crash.
It's going to crash and not delete the message, right? But if basically this says if we've already hit 8, skip everything else and just get rid of the message. Now you might instead
you might move it to another queue.
Do something here. Do something smarter, like move it to a different queue to keep track of it, or stick it in a blob, or just log that,
it to the
I got
table.
this message, but didn't know what to do with it, or something like that. That way you won't lose the queue, and you won't lose the chance to fix your bug, right? Like, why was this crashing the system, right? But you won't get hung up in this loop doing it forever. So you should probably do something smarter here. In this case, we're not going to do anything. We're just gonna let the queue message get deleted. So now if we run this some indeterminate number of times, we're going to see an exception.
Yeah, just a couple more, and then it's gone.
We don't know exactly how many times, but we're confident it's going to stop at some point. Was that it? That might be it. That's been a while. I think that's it. And so now it's moved on. It's basically gotten rid of that, or it's done something smarter. If
you can close this, right? You can stop it and rerun it again, and then if it just sits there, then we know it's gone.
Sure.
See, it's gone.
Looks good. So
ship it.
Use the DQ count. That's the tip of the week is check the DQ count to prevent poison messages from really killing your system and putting it in this infinite loop. Otherwise, it can be a real headache. And even if you don't think that you have conditions like this, I thought my Pig Latin converter was flawless until I put in the empty string. Things like this will come up, and if it's the case, if it's a website where someone types something in, hits enter, and it logs an exception, and then moves on, that's somewhat easier to deal with, right? The poison queue message that keeps you recycling or whatever is a real pain. So go ahead and put that DQ count in there, even if you don't think you're going to need it. Have it fire off an email to you every time it happens for all I care. Just have it do something so that you know there was a problem, and so you don't get hung up doing that work over and over again.
There's one other piece of trivia, actually, I want to mention. There's probably only 5 people in the world that will be affected by this, but if you are affected by this, you're going to just be scratching your head completely. If you've had a system in production for some period of time, like, I don't know, before PDC, 2009, The DQ count was added in a later version of
Oh,
the
that's a good
API.
point.
So what happens is if you created the queue with a version of the REST API prior to the PDC version, which I forget the exact string, it was like 2009, 417 or something. I forget.
Yeah, it was actually right. It was
Seven something.
It was somewhat earlier than PDC, but it was sort of that summer or something. But right, if you created a queue before that,
You won't have DQ count. Like it'll just come back 0 every single time, and you'll be scratching your head going, why? But then if you go recreate the queue, everything works. And it's just because the queue needed to be created with a version that included the DQ count. And that's it. That's the tiny, and like again, maybe there's 10 people in the world who are affected by this,
Right.
but they're going to be really
but
wondering.
right, those people are going to be so thrilled. Those people are going to be so angry when they find the show after they had to deal with that.
Exactly.
That's more like it. But yeah, that's a really important tip. Okay, so that was queues.
All right, and as always, if you see anything that you want us to cover, and we try to cover as much as possible, send us a message at Cloud Cover Show on Twitter, or send it to us via email, and you can probably contact us through our blogs. What's
Our
your
email
blog
addresses
again?
are up there.
Smarks.com?
I don't know, something that's the guy with it. Yeah.
Yeah. So just contact us. We'll try to get whatever your suggestion is on the show. And if you're Canadian, tell us, is it queues or lines?
Yeah, or something French. Okay.
Thanks.
Thanks.